Okay, so this next one's going to look at kinetic energy, rearranging the formula for kinetic energy, and just discussing around working out theoretical velocities and why they're theoretical. So our first part is, well, we need to know that Ke equals half mv squared. And they'll either give you that in the question. I'm not happy with that K. Let's do a slightly neater one. I'm not even sure if that is neater. But we've got to be able to rearrange this. It says here, an object's got 1,200 joules of kinetic energy. Brilliant, it's in joules. Mass is 5 kilograms. Brilliant. Calculate the theoretical velocity. Okay, so we've got to be able to rearrange this. So Ke equals half mv squared. And I want to get v on its own. Well, my first job is to get rid of half if I multiply both sides by 2. So I'll do this in steps. Times 2, and I'm left with 2Ke equals mv squared. Brilliant. So now you can see I've got rid of the half. Next bit is, well, the v squared is multiplied by m. So I'm going to divide by m. So 2Ke over m equals v squared. But the question doesn't want v squared, it wants the final velocity. So opposite of squaring is square rooting. And now I'm left with my formula, v equals the square root of 2Ke over m. And the 2Ke over here, where I put in lots of dots, that's where most people mess up. They forget to do that. So now I can just put the values in. So I'll just come across to here. So this is going to equal 2 lots of the kinetic energy, 2,400, square root sign, sorry, I'm going to have to try harder on my handwriting, divided by 5. So 2,400 divided by 5 equals, so this is the square root of 480. I'm going to square root it, and now I've got my velocity. Velocity equals 21.9 meters per second. So that's a tricky higher tier. This really is grade 8 plus. So be good at that. Next part, it says, why can this theoretical velocity not be reached? Well, this makes the assumption as I drop an object, all of its GPE is going to go to kinetic energy. Well, what's actually happening is as this falls, air will hit it. And as the air hits it, we're going to get some friction, and that's going to cause some heating, and we're going to dissipate thermal energy into the air. So our last part in saying this is some kinetic energy. You can see that same old answers needed multiple times will be dissipated as thermal energy into the air. And there we go. That's a great big chunk. I think that's the last bit of P3, the energy unit.